So here's the project. We are making a motion sensor that's supposed to scare your cat. And there's a little picture you're supposed to print out, but I don't have a printer where I am, so I had to draw my own. It's a little dog. Simple enough. So what it does is there's a light here that glows blue when nothing's in front of it. When something's kind of close, it turns pink. And then when something's really close, it turns red and it shakes the servo motor. So let's go over some of the components and then we'll give individual time to build it. So the first thing we're going to talk about is the servo motor. There's a couple different types of motors. There's DC motors and servo motors. Servo motors aren't for moving at high speeds, they're for moving a certain number of degrees. So this one, what we're going to have it do is just shift to two positions back and forth. Some of the other parts we got that we haven't seen before, you might have seen the LED last week, but this one is special and it can change colors. There's 4 wires in it, but we'll talk about that a little later. Next component is a distance sensor. It's this one with the two cylinders here. And so basically how far away something is, it'll tell you. We can write commands in the serial port to test how far away it is too. I know my co-president David, his distance sensor wasn't working too well, so I hope you don't, but you might have it dud, but you'll be able to check that once we build the circuit. The next part is this thing, which is a piezo buzzer. Piezoelectrics, what they do is they take a voltage input and they vibrate when you do it, and you can also take vibrations and use that to create electricity. They're also renewable resources. But what we're going to be using this sensor to do is it's going to take a voltage input and output a sound. And then we can change the level of voltage that goes through it, which will make the pitch higher or lower. And then everything else I believe we've seen before. Yeah. All right. So then let's start off. So first things first, I'm going to give you guys time to put wires in and set up each of the individual components. And so there's 4 components, we'll do 2 at a time. So I'll give you guys 5 minutes or so, and you guys can start off setting up the LED, which is going to be attached with 3 330 ohm resistors and the servo motor. And so there's a couple of things to note about each of those. So the LED, it's really hard to tell, but if you look around the bottom edge of it, one of the sides is flat. So of the 4 pins, you want that flat side be on the bottom of your breadboard. If you look in the diagram, it also says flat side, but the flat edge is really small, so make sure that you look carefully there. And that's the only tricky part with that. On the servo motor, you're going to want to match up the white and black cables to the white and black ones that are already attached to the servo motor, and then just follow the diagram from there. And so, yeah, I'll give you guys a couple minutes to do that, and then we'll join up. If you have any questions in the meantime, I'll be sitting right here waiting to answer them. I'm also going to rebuild mine a little bit just for practice. So go ahead. Even after saying all that, I put the LED in backwards still. So keep note, it's a little tricky. I'll give you guys a couple more minutes, and then I'll ask if anyone needs any more help. All right, anyone still working? No, we're good? Okay. I just set mine off. So the next part that we're going to be attaching is the distance sensor and the piezo buzzer. I think these are both pretty straightforward. Yeah, diagram shows it pretty well. There's 4 pins on the sensor. there's a ground, echo, trig, and UCC. Just make sure the ground one is at the bottom, and you should be good. All right, how's it coming? Do you guys need more time? Good? Speak now. All right, sweet. So now comes the fun part. I'm gonna boot up Arduino. And then I'll share my screen once it comes up. My computer's been running slow today, so we'll see how it works.
Also, quick note on the sensors Matt said earlier. I kind of had an issue with mine before, and now with different lighting, it seems to work fine. So maybe pay attention to that too. I don't know if maybe bad lighting can cause it to not work well, but may have to play around with it a little bit to get it working.
Alrighty, can you guys see my screen? Good. All right. All right, welcome to Arduino. We are gonna open up 3C motion alarm. It's gonna be somewhere else because you guys haven't opened it yet, but that's only for you to know. Wherever you saved it to. All right, so I'll walk you guys through, and then we can download and test out to see if your circuits work. And then I'll stick around for a bit and we can troubleshoot. So it's spelled out what each of these do, but I'll go over it again. Remember, there's two sections. There's the loop section and the setup section. And then before all that, there's this other stuff. So we're gonna include the servo library. What that does, it tells Arduino to put extra information in that it normally doesn't have. So it goes and just adds the servo library that has all the information on servo motors. It's gonna add some ints so that when we call them down here, it's gonna say whenever we go to red, green, and blue, it's gonna tell it which pin that is. Same thing with the trigger and the echo for the distance sensor. The float distance equals 0, and that's gonna measure the distance from the distance center. The pin that the buzzer is on. Servo, my servo, basically that's the name of the servo right there. And now we're getting into the setup section. So the first thing that we always do in the setup section is do serial begin. Then we move down to the trigger and echo pin, and this tells them what to output. Set up the RGB LED, simple enough. Output, buzzer output, and my server attached 9 basically tells you which pin the servo is going to be commanded from. And then the interesting stuff comes. This is the actual code. So distance equals get distance. We're making new variable distance, and then we're going to print that in our serial monitors, which you'll remember from last time, and I'll go over that after we upload. Serial print in, that's just going to put the inches on the distance. Fun stuff. And here is the if, else if, and else statements. So if you're close to it, under 10 feet, the LED should light up red. I think I got a bum LED on this. Mine actually lights up blue, pink, and red instead of green, yellow, and red. But if you're under 10 feet, it should just light up red. And it's going to tell the buzzer to output at any speed that you want. I actually bumped mine up, but I think it says 272 for you guys. But I made mine a little more annoying and high pitched and made it 572. You can put it at whatever you want. Lower number is deeper. You do you. My servo write 10. It's gonna tell the servo to move, and then it's gonna wait 1/10 of a second. And then it's gonna tell the buzzer to stop making a tone. And then it's gonna tell the servo to move back. And then it's going to wait another 1/10 of a second. So basically, every 1/10 of a second, it's just going to adjust back and forth. We move on to the else if. This is, actually, I'll talk about the else first. So if it's not any of these two conditions, what this else statement's going to do is tell the green pin to come on and not do anything else. The else if means that if it's more than 10 feet right here and a distance under 20 feet, then it's going to put the red and green pins on, which together should make yellow, but again, mine makes pink for some reason. That's just a mistake. I was playing with it for a bit and it still isn't looking quite right. And I don't feel like tweaking the numbers forever, so and I kind of like the pink light. So yeah, so if it isn't either of these conditions, it's going to go to the else. So if it's above 20 feet, it'll do the else. And then no matter what, after all these, it waits a tenth of a second before moving forward. And it's going to do some stuff down here. This is basically calibrating the distance sensor, and it goes to a distance function, and then it's going to display the time. So you guys can just upload from here. Again, the serial ports might give you a little trouble, but I'm hoping it doesn't. So let's rip it. That's my old code. I just changed it to change the pitch of the buzzer. Come on. All right, it should stop soon. Compiling sketch. Yeah, my computer is going slow today. I'm getting an error. Oh, error compiling. So again, if you get this error compiling, might be because your port is wrong. You just want to make sure that everything's plugged in well, which mine definitely is because it's going, and then try some different COM ports. If your Mac, it should have numbers. I don't know why mine's being annoying, and I already have the code downloaded, so that's why it's working right now. Come on. This noise only makes it even more annoying. It's gonna drive me crazy. Pretty sure it is COM8. I don't know why it's bothering me. All right, I'm just gonna do it with batteries since I already have my code downloaded. And I'll show you what it looks like, and then let me know if it's not working. So it should look like this, except your light should be green and not blue. Your picture that maybe you printed out ahead of time attached to the paperclip and tape will do its thing. Then if you get close to it, it should wiggle, scare your cat, whatever you want to do. And then if you get the medium distance, it should show this medium distance color, which for me is pink, but for you should be yellow, I think. I don't know. I got a bum light.
It should be yellow.
Any questions? Did that work for everyone? Sick. Okay. So that's about it for this week's lesson. And I'll see you guys back here next week. Feel free to try any of the kits. If you like any of them, let us know. If there's any that you want to try, let us know. All right. You can shoot me an email. If you're watching at home, feel free to email me. I will answer questions. We can do a Zoom, or I can do it over email, whatever you want. Happy building.
Hey.
All right. I'll see you guys.
See you guys.
Appreciate you guys coming out.